All right, welcome back, everyone. We talked a little bit about span tree. Now we're going to actually go inside and we're going to understand the election process and a couple of terms that you need to be aware of, okay, with spanning tree. All right, as you see, we're going to work with two different examples. So you see how the root bridge, the root ports, designated forwarding ports, all that comes about and having to look at it, all right, within 2 switches or 3 switches. So now said, let's get inside and let's get this done. All right, welcome back, everyone. We're inside the lab. Yes, we are. Wow, we're just going to explain the difference between the spanning tree election. When I say explain between, I mean between 2 switches and 3 switches. Okay, so what I did here, I haven't done any configurations whatsoever. I just had 2 switches, 2 random switches, put them up there. 3 random switches, put them there. Connected them with a proper cable, which is a crossover. And then out of spanning tree, because spanning tree is on by default, as you already know. And it does its job, because its job is to prevent loops. So here we see in the top example that we have 2 switches, 2960 switches, and they have 2 crossover cables plugged into the fast Ethernet 01 and 02. And apparently one of these lights is amber. So what does that tell us right away? They say, hey, this is in blocked, right? Now, working with a packet tracer for a very long time, it's very easy to realize, which is blocked. This is blocked. This is a root port, and these are designated ports. Why are these designated forwarding ports? Because they're in the root bridge. If they're in the root bridge, there will all be designated forwarding ports. Yes. They're not going to go crazy. Some people ask me, hey, Laz, but what if there's 4, 5, 6, 10, 20, 30 switches? Then I say, well, good luck to you. All right? You're not going to calculate it yourself. Okay? That's why we have software and everything that manages things for us. And besides, you shouldn't be messing around with spanning tree. You make a decision on who you think is going to be the root bridge, and I'm going to show you how to manipulate later on the course who's going to be the root bridge. But this lecture is to show you how it does the election. So what it does, it says, since it's based everything on layer 2 addresses, it says, okay, I got redundant connections between these 2 switches, and I need to make a decision. So I'm going to look at the bridge priority number. But the bridge priority number by default is 32769. And it's 32769 on all switches. So guess what? It can't make a decision. We need something else to look at. So what do we look at? We look at the lowest MAC address of the switch. So let's take a look at the root bridge, or what I think is the root bridge. All right, let's open that up. And how do we look at this stuff? So we do show spanning tree, right? You can do VLAN 1 if you want to. That's the only VLAN there, but show spanning tree. It'll show you what you need. Now, one thing I wanted to say right off the bat, this portion right up here deals with the root bridge, okay? This portion down here, this information, oops, okay, hello. This information down here deals with the switch itself. So here is telling us, okay, the bridge priority is 32769. Yes, we already know that. We all have 32769. And it's even telling me, hey, Laz, I'm the root bridge. This is the root bridge. I'm like, oh, okay. But why? And you can see here that the MAC address for the switch is 0002, and then you get the rest of these numbers, right? So since we can always see this information, and this MAC address is the same as this MAC address, let's take a look at the other switch and see what the other switch says. So open it up. There we go. CLI, we're going to do the same thing. Show spanning tree. All right. And here we have the root bridge, right? And it says, hey, 0002. And we saw that. That was the other switch that we just came from. But this switch is 00E. So its MAC address is higher. So in the election process, it couldn't use that 32769. So it said, you know what? I got to use the lowest MAC address to create the root bridge. And it did. And the other switch is now the non-root bridge. Okay, because it has a highest MAC address. So it's okay, well, what's going to be the states of my ports? Well, the state of the ports on the non-root bridge, okay, in this particular scenario, it's going to be one root and the other one is going to be blocked. So it's going to pick F01 in this scenario, and it says, hey, I am facing the root bridge, therefore I'm a root port. But hey, F02 is also facing the root bridge. Wouldn't he be a root port also? Well, no, the whole purpose of span tree is to stop forwarding. So it's got to make a tiebreaker, a decision, and say, hey, listen, this is the highest MAC address of the switch. So now we got to go to the ports. So in the ports, we have the same bandwidth. The cost is 19, which is the number set for fast Ethernet. So I got to say, F02, well, F02 has a higher MAC address. And let's prove that. And that's why that's being blocked. So it boils down to the tiebreaker of the port number with all these variables. So I'm going to do show interface F0/1. And you can see right up here. You can look at this. This is the same thing. Okay, that's the MAC address of port 1. So what I'm going to do is I'm going to up arrow and do 2. And I'm going to look at 2. So 1 is 1, 2 is 2. You see that? This is 9601 and this is 9602. So it had a higher MAC address. Therefore, that's why it chose this switch right here to be blocked. And that's what you look at. When you're taking your certification exam, that's what you want to do. You first want to isolate who's the root bridge. And the root bridge is the one with the lowest bridge priority number or the lowest bridge ID. And what is a bridge ID? A bridge ID is a combination between the bridge priority number and the MAC address. So the lowest bridge priority number and the lowest MAC address out of all your multiple choices that may come up, that's the one you choose. Okay, and if you have like a print screen or design or something you're looking at, obviously you're not going to have lights, but they're going to give you the MAC address and the root bridges. So the first thing I want you guys to look for is the root bridge, because right there, right off the bat, and let's go to the root bridge again, if you don't mind. Okay, let's maximize this, and we're already there. You see that all the ports are designated forwarding. All the ports on the root bridge will always be designated forwarding. All the ports facing the root bridge will always be root bridge or root ports. Okay? So, well, you say, hey, Last, you just contradicted yourself. You said that all ports are root ports, but this is facing the root bridge, but it's not root port. But like I said, the whole purpose of spanning tree is to block forwarding. If I were to turn this green, then I will turn off spanning tree on this port. Spanning tree won't look at it. It'll turn on. Then it's just going to keep forwarding and forwarding and forwarding and forwarding. And if that's the case, what happens? A broadcast storm. So we don't want that to happen. Okay? So that's an example with 2 switches. And I did the same thing with 3 switches. All right? So you already know that this is the block switch right off the bat because it has an amber light, right? But who's the root bridge? Well, I said that all ports facing the root bridge must be root ports or the lights are green. Well, he's facing this switch. His light's not green. So guess what? He's not the root bridge. He's the root bridge. Why? Because, hey, look, green, green, facing, facing. Let's see if that's true. So spanning tree, and you can see it says, hey, I'm the root bridge. And my MAC address is 0001 and then the other numbers. Okay? And you can see they're designated forwarding because we're all using fast Ethernet interfaces. That's why the cost is 19. Because really Cisco calculates the cost to the root bridge, and you become the root bridge if you have the lowest cost, okay, to get to you. All right, so let's go over here. Now let's take a look at this one. All right, this is not being blocked. All right, so what's going to happen here? Here we have a root port, root forwarding, and a designated forwarding port. Here it has to forward information. So it's going to forward information out. But you can see its MAC address is, because remember, this portion right here deals with what? The switch itself. We already know this information. We saw it on the root bridge. We saw the MAC address, right? 0001. Well, this is higher, 000D. It's higher than 0001. So that's why he did not become the root bridge, because they're all using the 32769. Okay, so let's bring this down. And then let's pick this guy here. And let's see what his MAC address is. Oops. All right, and he has a 000E, even higher. No wonder they picked him to be blocked, okay? So that's the case, and that's the case. So that's how spanning tree actually chooses its ports, okay? It chooses its ports to based on what first? It looks at the bridge priority number. If they're all the same, it goes to the lowest MAC address. Now, obviously, the combination between a MAC address and a bridge priority number, that becomes the bridge ID. All right, but the one, just to go by the book, the lowest bridge ID becomes the root port, or the path, the least cost path becomes root bridge. Okay, so to go over it, root bridge, right, has the lowest MAC address because all the bridge priorities are the same. This is not the root bridge because it doesn't have the highest MAC address, so it's designated a non-root bridge. And its ports, the ones that face the root bridge, will become root ports. Facing anywhere else, in this particular scenario, will be a designated forwarding, because just because this is blocked, it's blocked from forwarding, but it's not blocked from receiving. So he'll still receive information, he just won't forward out any information out of the port. That's where the forwarding stops, to avoid broadcast storms. All right, so that's spanning tree election process right there. But there are some terms that you need to be aware of, and we were going over it. Root bridge, root ports, designated forwarding ports, and block ports. Okay, this is what STP has. Okay, so, but you can tweak all this. You can tweak the bridge priority number to what you want, and we'll be doing it later on in the course. So, ladies and gentlemen, this is the election process of the root bridge. I'll see you outside the lab. All right, that wasn't so bad. We now, in the packet tracer was easy, right? We saw an amber light, we know that's blocked. So we know that this is the root bridge, right? Designated forwarding, and this is a root port facing the root bridge. Likewise here, you see that you have an amber light, that's a block, it's facing that guy, so that guy's on the root bridge. Is these two green lights right here facing that. So we know that that's the root bridge, and it was based on what? The lowest MAC address, because the priority ID was the same. We saw all that, all right? But again, we can manipulate that. And I'll show you how to do that. So we can choose which switch can be the actual root bridge, all right? And again, yeah, that was pretty simple. You can manipulate the election. Now, warning. People ask me questions. Labs, what if you have 4, 5, 10, 15, 20, 30, 40 switches? I tell them, don't worry about it. Okay? Span tree works on its own. All you guys decide who's going to be your main root bridge, your beefiest bridge, the bridge that's going out towards the internet, whatever the case may be. That's it. Or not pick it at all. Let it pick it itself. Okay? Because it will find the purpose, remember, finding redundant loops to avoid broadcast storms. And to be honest with you, and networks out there, there's probably no redundant loops. It's just one core switch or 2 core switches, and then the cables are running out to all the other switches to their offices or classrooms or whatever the case may be. But anyway, and that's one thing you need to know. Span tree only comes alive when it sees that there's an actual redundancy. Okay, redundancy. Anyway, now you know the secret. I'll see you in the next one.